excuse me. With the next three, just blow those up. On 4, what was the one thing you had to mark? Or one thing you could mark, I should say. Thank you, sir. Again, you can only mark here. You got your shared side, your reflexive, and that gives you which of the 4. We've got 2 sides and an angle, so side angle side. Side angle side. Remember, I want you guys to remember, as you go through a side, the next thing should be an angle before it gets to the side. That's why we draw the pictures of what it looks like. When you get to when we get to these, I'll remind you guys why it skips this middle piece here as we go along. So this was your side angle side. And again, if you wrote triangle ABC, if they want ABC, it has to go SBC. Okay. As long as those letters match up, you should be good to go. I've had a lot of questions about number 5. Is there anything else you can do with number 5? No. Do you see an angle anywhere? Does it show, does it say that they're congruent? Can you assume that they're congruent? There's nothing you can do here. Okay? There's nothing we can do here. Yeah, there's nothing we can set these things up to make it work. Okay? On 6, obviously, again, you've got your shared side here at AC. But if you do that, what do you get? Is there such a thing?
No.
Nope. Because there's no. Very good. All right. There's no. You're very proud of yourself for chanting that, aren't you? So this one's also not possible. One of the things that we're going to do tomorrow, or not congruent, not possible, however you want to do it. Remember, I know I don't really use them all that often, but please make sure you've got your Chromebooks tomorrow. There's something that Seb and I had created a few years back that I haven't used in a while since we got the new Chromebooks, because the way that the websites worked, it didn't work on Chrome. He was able to find a way to make them work again, and what we do is we try to manipulate given segment lengths, given angle measures, to try to create the different ways of doing congruent triangles. We do it virtually because there are some cases, it explains a little bit more why side-side angle doesn't work, or why there is no asymptotic. You can kind of explain, it helps show it a little bit more visually of why it doesn't necessarily work. Next 3, same idea. What I was asking that you guys do was mark anything you possibly could. In the first one, hopefully by now, when you get used to seeing that bow tie style of the picture, you're picking out and thinking about the vertical angles. So if you were marking them through the verticals, then that would give you side angle side. The angle is between the given side lengths. So if you say side angle side, then I would say triangle ACB. 1 to inside out, it would have to be PCQ. Right. Triangles and the proof stuff is probably the one point in time in geometry where you have to be super, super specific to make sure your lettering matches out. After this, the kind of opens up and gets a little bit easier through that. Same thing on 8. Still have vertical angles, but you got angle side side, and we all know that doesn't work. Go ahead. Correct. All right. 9, you have to do a little bit of work. It's not anything difficult, because how many degrees are in a triangle? 180 in the triangles. So as you go through on this one, the trick was, obviously, you've got a reflexive side between the two, the shared side. But what you needed to do is figure out these third angles. 60 and 61, back that out from 180, it gives you 59. 60 and 59, back that out, gives you a 61. That gives you your 2 sets of congruent angles. So you could have used angle, side angle with this. Or if you did, because you had the 60s here as well, angle, angle, side, that would work. Or angle, angle, side going this way. Either one of those would have been just fine. Matter of how you put it. So if I say, if I go A, C, or sorry, A, G, C, then it would have to match with A, B, C. And it's really easy when you have them with numbers. Okay. So far, so good. Hopefully the letters aren't messing you up. Okay. I think the next were the ones with the parallels. No. Yeah, parallel, 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 parallel. We had last one was 15. That one should have been really easy. Once again, you wind up with a bow tie style. Whenever you see that one, you've got vertical angles. So if you've got your vertical angles, you know that works. And then again, as you follow through, you've got angle, angle, side. So. Remember, the reason why it's angle, angle, side is as you're reading through these, you go from angle to the angle, then the side. You don't read it angle. If I'm going this way, I have the angle here. There's a no mark side, a no mark angle, then a side. There's two nothings that are marked. You don't go that direction. You always go the shortest direction where the next marking is. Does that make sense? It's kind of a weird way of trying to explain why you go that way versus the other. So remember, if you've got angle, angle, side, angle and the angle are next to each other. This is 1, 2. You guys agree that there are 6 parts to each triangle? Yes. 3 sides, 3 angles. If you start at one of the angles, there's only 1 space between the 2 here. If I go this way, there's 2 spaces. You always go shortest distance. That's why that works. Okay. I really can't think of any other way of reminding you guys of that. Other than maybe it's always angle, angle, side if the side length is across from one of the given angles. That's another way of thinking it. Go that direction. Okay? That means your last one will be that side. So if these 2 are across from one another, you make sure that this is the first and that's the last. Just trying to give an easy way to remind you guys on that one, because that's where people tend to screw up. Okay? So, not terrible. So as we start adding more and more to these things, I think what I did on the first day is I gave you guys proofs, like right off the bat. I said, here, sink or swim. And most of you guys did just fine with that. But what I wanted to do then yesterday was kind of pull back and start, at a slower pace, excuse me. So today we're going to kind of take it one step beyond where we were at yesterday, not doing a proof right off the bat, but then going into marking diagrams with what you can show. Kind of like what you were doing here on this sheet by just looking at the pictures. Here they're going to give you the information and you have to completely mark the diagrams. Whatever. Okay. And I apologize, I forgot to hole punch this. So, on this one here, I want to look at, let's see, we're here. Excuse me. What I want to do right off the bat on number 1 is I want to change one thing. On the information for number 1, you'll notice, shh, ladies and gentlemen, not now. You will notice that there is a given statement and it tells you a proof statement by the triangles and it says by blank. Well, we're going to figure out by what these things are congruent. But first thing I want to do is I want to change this second piece here. This second given statement uses something that we don't worry about. So I want to go ahead and change it real quick to just BD is congruent to CD. Okay? I just want to change that real fast. And I'll explain to you guys here in a little bit why I'm doing that. Now, with this style of proof stuff, we're not doing the 2-column proof, but you'll notice you have a given statement that has a progression. When you're given something that's perpendicular, what happens? 90-degree angles, right? What do you know about 90-degree angles? They're all the same, right? So what we do is AD's here, BC's here. We know that we have the 2 right angles that are formed. So we'd mark it. What else is given to us? What would we do? At this point in time, you've got 2 parts of both triangles that are marked. You got to figure out the third. What would be the third thing you have to do? Reflexive, yeah, the AD. Now, notice the difference between what you did last night and what we're doing right now is last night they gave you those 2 first pieces, you had to come up with the third. Here you're reading instructions to figure everything out. So these 2 triangles wind up being congruent then by what method?
Side angle side.
Yeah, it goes side angle side. Okay. Now, put your pencils down for a second. If I had this originally the way it was, you still have the right angles, then you had these 2, and then you have reflexive. What is that? It's ass. But what kind of a triangle is that? The right triangles. What do you know about right triangles? There's 3 spots, right? An A, a B, and a C. Remember the Pythagorean theorem? A squared plus B squared equals C squared. So let's say, for example, let's draw this real quick. This kind of looks like the one we had a second ago, right? And it gave us, we knew that these 2 were the setups with the right angles. If this is 10 and this is 8, what does that have to be? 10, okay. Now, do you guys agree that this triangle here has a hypotenuse of 10 and one side length of 8? You would use Pythagorean theorem to find the missing side length, right? 10, is that the hypotenuse or is it a side length? Why is it a hypotenuse? You guys remember the rule? The biggest. Well, do we know it's the biggest one versus the other one? Well, where is it across from?
It's across from the
Hypotenuse is always across from the 90. These are things that you haven't technically learned yet, but yet you know. So we know that the 10 has to be the 10 squared. It has to equal something squared plus 8 squared. Do you also agree in this triangle on the other side that it's still the hypotenuse and the 8 is still the other missing side length?
Yeah.
What's 10 squared?
100.
What's 8 squared? Subtract them, what do you get? 36. What's the square root of 36? So wouldn't the 6 have to go here and here? What happens here is this thing called hypotenuse leg. It's not one that I'm going to worry about with you guys. Hypotenuse leg is the version of angle side side that actually works. And it only works because you have a right triangle. And it only works because the right triangle has Pythagorean theorem. It's the only reason why it works. Okay. So technically there is an ass in math, and I've been lying to you. I know, but I'm sorry if I could just look like, my heart is trying to lie to me, the worst day ever. Maybe not so many words, but yes, I'm an idiot. Yes. in this case here, this is one of those things that you'll see again when you get to Algebra 2, when you do something that's called law of sines. Don't worry about it for here. I promise you not to make anything that gets into this style. So you'll go back and you'll worry about side angle, side stuff. You will get the hypotenuse side. Does that seem fair?
Wait, so if you had like 10 and 9 instead, it became like.
It would still work.
It would still work.
Yeah, because if the 9 is shared between the two, you just would have a different decimal or something in those two pieces. I was using what are called Pythagorean triples that work cleanly. So in this case, I was just trying to show you an example, so no big deal. Look down to number 3. Number 3, you have a midpoint, and you have a given another piece that's given. So think about your progressions. What do you do when you have a midpoint? What do you mark?
The middle.
Well, not the middle. What do you have to mark according to your diagram? What do you know for certain? Two sides are what? They're equal. So if D is the midpoint of AC, what are the two parts that have to be equal? AD and DC. So in your diagram, you should just be going, oh, I know this has to happen. Okay? I know that has to happen because of this. Okay? What's that? Does it say that it's 90 degrees? So you can't assume that it's 90 degrees because then all of a sudden you make an angle side to side out of you and me. Assume. No. Anyway, AB and BC. You have two sides of both triangles. Can you get an angle in between? Can you get a side in between?
Side.
Very good. And you just mark it up, knowing that the last piece that you have to get there will be the reflexive property. Now, on your progression sheet, you have a picture of shared side. You have what it looks like, what to be looking for. That shared side is a super common thing to find. Yes, ma'am? It doesn't say that there is, so you can't assume that it occurs. Okay? If it doesn't say that these two are perpendicular, you can't assume that it happens. Whereas in the other one, it said it was, so you know it is. Okay? Now, there's properties of, you know what an isosceles triangle is? What's an isosceles triangle? Two sides are the same. Good. So, anytime, and this is something we haven't learned yet, this is one of the properties that we learn next week. Anytime that you have an isosceles triangle, those two sides are always the same. Okay? Those two sides are always looking at what are called base angles. Those base angles have to be the same. And then anytime that you draw in something that bisects the other piece, it has to be a right angle. But you don't know that yet, so I didn't say any of that, so you can't say it. That's something you'll learn later on. Okay? But that's something you'll never use in a proof. That's something you'll use for algebra. Okay? Take a second and try numbers 5 and 6. Again, I'm not going to give you guys anything that has to deal with parallel, so don't worry about anything anytime you see parallel lines. I'm not going to give you anything like that. Mr. Fontana and I have decided that we don't need them. They're not tough, they're just too much work. Okay? All right, first one. Should have been really, really fast. What's that? No, why? So if P is the midpoint of AD, what are the two segments that have to be the same? AP and PD, okay. And the other two are here. That looks like the bow tie, which means you're going to have vertical angles around the middle there. So you've got these two. So you get, just like you said, very good, side angle side. Okay. Are you guys that excited? Yeah. Are you? Air 5. You can have air 5 if you want. Let's go. All right. Okay. So what do you do here then? Well, you have an angle bisector. We haven't seen one of those in a while. It's like maybe 20 hours, 24 hours, something like that. So, yeah. So long ago. Angle bisector does what to the angle? Thank you. Yes, bisects it. It creates how many congruent angles? Two of them. So now it's just a matter of figuring out where it happens. So it's up between those two. Why can they use just one letter for angles B and C?
No other angle.
Good. No other angles can occur there. Shh, gentlemen. And then last but not least, we've got two angles, which means we're either going to be angle side angle or angle angle side. What are you going to wind up with? Should wind up with angle angle side because you're going to get angle angle side. The reason is the side is not between the angles. The side is across from one of the angles. That's an easy way to tell the two apart. Okay? It is, the side is across from one of the angles, not between, so you have angle, side, angle. I think the last one that you can do is number 7, because the last one's at, well, so take a second and do 7. And I think we might call it a day on these. Waiting. Yeah, in this case, it's kind of sloppy how they did just bisects angle A. They should have used the 3 letters, but ladies and gentlemen, A is the angle, yeah. Remember, in this case here, they're talking about the large angle A, so you get those two have to be the same. Same deal here, when they're using just one letter, talking about the large angle here. So you've got 2 angles, which means you got to figure out where does the side come into play. Is it between the 2 angles, or is there side across from one of the angles? it's going to be between because it's reflexive. So you've got angle, side angle, okay? Notice what you've been doing here is really just one step beyond what you did yesterday, okay? There really is not that much difference between the two. The next natural step then for this is to do a couple of these completely on your own, which should not be all that scary at this point. A couple things to remind you. I think I mentioned this earlier, don't forget to bring your Chromebook tomorrow. I want to do something online with some congruencies, because we'll go over a few of these proofs and do some of those. And then Friday, I've got a real short proof quiz for us. And it should work out cleanly for us, because then we can take this proof stuff that we're doing and show you guys next week what's the next step that you can do after it. And it literally is just one more step. Right? It's not anything different. Okay? So take a look at, ladies and gentlemen, one. Take a look at number 1, please. Well, first of all, I want you guys to add up on the top here, angle, angle, side also, an AAS.
It's right there.
No, it's angles. Is that right down there?
Yeah.
Oh, I did. See, look at me.
Yeah.
All right. Also, the reason why I put all these little lines in here was just to kind of help space it out a little bit for you, because some of your handwriting is, and some of your handwriting is decent. No offense. I could be talking about, Brooklyn. I mean, hers is awful. You don't need to use all the spaces that are given to us. Sometimes you do, sometimes you don't. Sometimes you might need to write one extra. It just depends, okay? There's no reason for one way or the other. So, as I get into this very first one gave you 2 givens, and it told us what to prove. So, we look at our givens. Make sure your progression sheet's out. First given says you've got perpendicular. Becca, I heard you say right angles. All right? You noticed right away that once you see perpendicular, you look at your progression sheet, it tells you state the right angles that are formed. So we go to our diagram like we have been doing. We draw in where the right angles occur. Then we write them down. Angle A, B, C, and angle D, B, C are right angles. And according to my progression sheet, it tells me to write definition of perpendicular. Now, after that, it tells you on the sheet to do what? It says right angle congruent to right angle. So I just said they were right angles, and now that I say that they're congruent, my reason was all right angles congruent. Okay. When you have perpendicular, you've got 3 steps to go. We just did the 3, because that's what the sheet says. So you look at your next kit. Next one says BC is the angle bisector. BC is angle bisector of angle C. Okay. Once again, that's given to us. On your progression sheet, it tells you when you have an angle bisector to state the 2 angles that are congruent now, that are formed. Well, if I'm down here, it's got to be those 2. Angle ACB congruent to angle DCB. So, At this point, those first 5 steps are literally in front of you on your progression sheet. Now you just have to cross-reference, well, according to your picture, you have 2 angles that are matched up. So I have to figure out, do I have a side that goes between the angles? Do I have a side that's across from one of the angles? We have one that's between because of what property? How do I state it? BC is congruent to BC because of what? Reflexive. That's why I just went pre-C, reflexive. Can I say BC or do I have to say CB? Either one as long as I say it twice, okay? Isn't there a picture of what reflexive property looks like in your sheet? Yeah. Now, there's pictures of all this, right? Yeah. So it's just a matter of using the correct letters that they gave you to write out. And this was angle, side, angle. Okay? Take a look at the next one. Look at the 2 triangles that are on number 2. What do they have in common? When you look at the picture. What property are they going to have to use? Reflexive, aren't they? See how it's got that diagonal between the 2? Look at the third one. What do they have in common? Reflexive again. All right? Wait, do you sense a pattern?
No.
No, right? Look at the fourth one. What do they have in common? A reflexive side again, don't they? The fifth one doesn't have a reflexive side, but it looks like a bow tie, which means what should it have? Vertical angles. And then the last one looks like it has something in common again, doesn't it? Boy. Gee, are those the missing steps, you think?
I don't know.
That's usually what happens with these things, guys. You don't have to come up with much of it on your own. What you have to come up with on your own is just making sure the letters match. This shouldn't be that bad. We've done a boatload, I almost said another word. We've done a boatload of work to get to this point, okay? Give these a shot. We'll go through a few of them tomorrow. I got a simple activity to show why certain things work the way they do. Friday, we've got a short quiz on it. We'll clear it out for the weekend. We'll do corresponding parts on Monday, all right? Shouldn't be that bad. I'm still thinking I don't know if we'll be able to test on this by the end of next week. It won't be the end of next week. It'll probably be like Tuesday of the following. Should be somewhere in that neighborhood. We're pretty close. Yes, ma'am. I have like 3 or 4 proofs. So nothing more complicated than this. Just a straight proof. Okay? It'll be triangles. No segments, no angles. Okay? Just be the triangles that we've been working on by showing one of these methods. Okay? Give them a shot. You should do well. Did you need one for her? Yeah. Okay. I knew I passed on to spare. I just want to make sure you got it. Yeah. I'll get it 1 second.